So in this video, we are going to take a look at the differences between the public web and the dark web. Why is it called the dark web, and what exactly is it used for? Where did it come from? And what, all that good stuff. So the first thing that we're going to do is we're going to talk a little bit about the public web, the one that you use every single day and the one that you're using while you're viewing this video. So the way that this works is we have, and it really is kind of like what we have when you think about your house. So you end up with your house, and it's sitting here and it has an address. So let's say it's 121 Free Street. And so this is the address, and let's say that the Hancocks, I gotta make sure that I don't actually, so let's say the Hancocks live at this particular house. So when we get ready to mail something to this place, or we are going to drive to this place to visit them, we would go to our GPS and we'd put in 121 Free Street, and then it would take us to that address, which happens to be the Hancocks. Now on the public web, what happens is we can keep our house, but we're going to turn it into a server. So we're going to say that this is a web server, and we're going to say that this particular address is www.google.com. Now that's who lives there, but the actual address of this particular server might be 20.20.20.20. and this is not a realistic address, but it's basically what it looks like. So if we were to go to the computer and tell it to go to 2020, well, what happens is there is a DNS server, which is domain name server, and there's a number of these servers that are all over the world. It would go to that server and it would say, hey, I'm looking for this company, this website, www.google.com, and that DNS then goes into its database and it looks up google.com, and then it returns you this address, because the internet itself doesn't have the ability to just go to google.com. It doesn't know where that server is sitting. So google.com is a domain name, and then there's a company that gets paid, because every company or every person that has a domain name or has a website has to pay for their domain. So every year they have to pay a company to have that domain name, and then that gets registered on the DNS, and that's how all this stuff works. So it's really no different than your post office box, or not really your post office box, but you're registering with the post office that you're currently residing in a particular house. And if you move to a different house, then you register that new house with your address, and then any traffic that used to go to the old address will then get redirected to the new address. Same thing here. If I take my server and I move it out of the data center that gave me the address of 2020, and let's say that I move it to a new data center and they give me an address of 102.123.124, whatever, and they're 4-digit numbers, so we'll just say that this is the address that they give us. Well, what I would do then is I would go back over here to the domain service and I would say, hey, I need you to re-register google.com and make it point down here to this guy now, because I've moved the server, I've changed the IP address, and that's basically what's happening. So And it gets a little bit lower level than this, but I don't want to really get too complicated here. But this is the primary user side of what is going on when you actually communicate with a server that's out on the internet. Now, the thing that happens with this as well is that you're getting your internet through a service provider. They're called an ISP. It's an internet service provider. So if you go to your cell phone and you open up a google.com over there, or you go to your computer while you're at home, or you then go to work and you get on your computer and go to google.com from work, that ISP is able to see all of the web pages that you're going to, because all that traffic is coming across their network, and it can't encrypt DNS traffic because it has to know where, everybody's got to know where that traffic, what server are you trying to go to. And so everybody that wants to know can know. They may not be able to see the actual traffic going back and forth, but they do know where you're going and what you're visiting, what kinds of places you're going to. So even if you go to the private browser window inside of Firefox or whatever browser you're using, and you tell it that you don't want it to track, well, you're telling the browser not to track your activity, and it won't. But the activity that goes over through the ISP can still be tracked. They can still see everywhere that you're going and what you're doing. So now that we have kind of a broad overview of the way the public websites or the public internet works, let's talk a little bit about TOR and what a dark web actually looks like. So I'm going to get rid of all of this stuff, and we're going to take a look at what it would be like if we were to actually use the dark web and how it differs. So the first thing that is different about the dark web is that the dark web actually has a different mechanism that it uses to communicate. So the first thing is that there are no IP addresses in the dark web. So that number that you saw me write where I put 102.168, whatever the number is, that is an IP address. So that's called an IP address, and these don't exist in the dark web. The other thing that doesn't really exist are domain names. Now, why do you not want these things to exist inside of the dark web, and what is the purpose in it? And the first thing to understand is your ISP can see everything that you're doing in the public websites. Your ISP or your IP address that you're using can be seen by the end person that you're actually communicating with, so they know where you came from, what city you're in, what house you're in. They know all of that from your IP address. And then, because to be clear, every single house, every single telephone all has a unique ID that actually can be identified at whatever you're going to. So if you go to google.com, they know exactly what phone you're on when you go to that website. So all of these things have been done away with in the dark web. And so what ends up happening is the very first thing that happens is that you have your computer sitting here. So this is your notebook, and you're ready to start communicating over the dark web. Well, the first thing that you have to have is you have to have what's called a TOR browser. Now, all a TOR browser is, it works exactly like the browser Firefox. In fact, I think it's copied off of the Firefox browser. But it works exactly like Firefox or Chrome or Safari or Internet Explorer or whatever the hell they're calling their browser these days. So it is the same functioning thing, and once you open it, you can go to google.com. You can go anywhere on the public web that you want to from that TOR browser. Now, what happens though before you can do anything inside of a TOR browser is that TOR browser is going to actually connect to the TOR network. Now, all the TOR network is a bunch of servers that are all over the world. So let's say that you're here, and let's say this is actually inside of your house. So this is your home, and you're working from the TOR. You want to work through the dark web. Well, what happens is that when you open up your TOR browser, that browser is actually going to connect to the TOR network, and it's going to tell the TOR network that I want access to the dark web. So what happens is your ISP, and this is a downside in the sense that they can see that you're, if they're looking, they can see that you're actually connecting to the TOR network, but that's all that they can see. And they would have to know the node address and stuff, because the TOR network is basically a bunch of nodes that are all over. So these are called nodes. So you have a node here, and let's say you have a node here, and a node here, and a node here, And then let's say, and there's a number of these things. I can't remember the exact number that it hops through, but then out here it ends up going to google.com. All right, so let's see how this would work. Well, the first thing is that we have an entry node. Now, an entry node is exactly that. It's the node that your browser is actually going to connect to tell it that I want access to the TOR network. So let's say that this is our entry node. And so what happens is we connect to that entry node and it provides us access to the TOR network. Now all of these guys are just nodes. They're just individual nodes that are in there. I don't know the exact number of these things that exist because anybody can run a node. Nodes have absolutely no idea what in the world is passing through them, and they don't have any idea where it came from or where it's going. Eventually, it is going to get to an exit node. So this is an exit node. So what happens is you connect to the node to the TOR network, and your TOR browser, you have to use a TOR browser because that browser knows to connect to an entry node before it allows you to go to any websites. So that browser connects to that entry node, and then and so now we issue a command, go to google.com. At that point, that entry node takes our traffic. Now your ISP cannot see where you're going. It can't see that you're going to Google. It can't, all of the things that it could see earlier, it can't see it all anymore. And the reason is because your TOR browser is actually encrypting that traffic from your computer to the entry node. So there's no way that anybody knows what website you're going to go to or anything in between. It has no idea. So you've protected yourself from that network knowing what is going on. The next thing that happens is to protect your data is it routes that traffic all through all of these nodes. So it bounces the traffic all over the world. And so these entry nodes or the middle nodes can actually be located literally all over the world. And so the traffic that leaves your computer in whatever state that you happen to be living in is actually it could leave the United States and go to Germany and then come back over here to go to another node and maybe go to Canada for a node and then come back. So tracking where you actually came from is almost impossible. It's not totally impossible. Nothing is totally impossible, but it is very unlikely that someone is going to be able to find you if you're using this TOR network. Now what happens out here let's talk a minute about the individual nodes. So the first thing is in order for the individual nodes to know that you're headed to Google, to google.com, it has to be able to open up just enough of that package to be able to read where it came from and where it's going, because it has to, if you think about it, when you go to your friend's house, you have to know how to get home. And this is the same thing. When you go to google.com, that package that you sent to Google has to know how to come backwards through this network to get back to your computer. Otherwise, it'd be kind of pointless. And so inside of these packets that go through this network, it holds on to where the actual end result is, where are we headed, and where do we come from. Now in this entry node's point of view, it actually knows that this thing came from your computer. So it knows that it's going to be sending that packet back to you, and it holds on to that inside of the packet. But it encrypts the entire packet from that point. So nobody that gets the node down here is going to, on this first node, for example, doesn't know where in the world this thing came from. So it decrypts just enough of it that is the conversation between these two guys, and it looks and says, well, this packet needs to go to google.com. I don't know where it came from. I only know that I received it from this node 1. So we'll just come in here and call this node 1, 2, 3, 4, and 5. So node 2 knows that it got the packet from node 1. It decrypts it and sees that it's got to go google.com. It knows how many nodes it's gone through so far, and so it sends it on to another node because it knows it's not ready for an exit node yet. And so it sends it on to another node. It does the same thing. It opens up and says, okay, well, I got this packet from node 2, and I'm going to go ahead and send it to node 3, and so or node 4, and so it bounces it and eventually ends up over here at, and I keep hitting my pencil and turning on the eraser instead of the pen, and so it ends up over here on this exit node. Now at this point it has to decrypt the traffic. It can no longer keep it encrypted because Google wouldn't know how to read it, and so at this point it actually decrypts the traffic and sends it on to google.com. The thing is, though, is google.com doesn't know that you're the one that's communicating with it. It thinks node 5 is the one that's actually communicating with it. So its conversation that it's having is with node 5. Now, when it has a conversation, node 5 takes that conversation and it sends it backwards through the list of nodes that it used to communicate, and it eventually comes back over here to your computer. So essentially what we've done is we've completely hidden Google so that they can no longer see where this traffic is coming from, and we have isolated our traffic from our computer to the node itself so that they don't know that I was ever even going to google.com. So it's a pretty safe network. You open a TOR browser. It's a free download that you can get on TOR. We'll take a look at the website here in just a second. In fact, I'll go ahead and jump over here to the computer, and we'll go to down here, TOR project. So it's torproject.org, and you'll just come down here to the bottom, tell it to download the TOR browser, and then it'll ask you what operating system you're actually downloading it. So they have one for Windows, OS X, Linux, and Android. I don't know if there's one. I'll have to look to see if there's one for iOS. Apple may block it. I don't know. But there, you can get it on your computer, which is typically where you're going to use something like this. Now, the next question is when you actually open a TOR browser. In fact, we'll go ahead and download the one for Apple here and save it. And then we'll open it up. And we'll get this installed here so that we can run it, and then we'll take a look at what is happening. So that opened into, oh, it's up here. All right, so all I'm doing at this point is I'm copying the TOR browser into my applications folder. And so now we're just going to go up here to applications, and we're going to go to TOR browser. So down here is TOR browser. Now watch what happens when this opens, if Apple let me open it. So right now we have a configure and a connect. So what I want to do is I want to actually connect to the TOR network. So before it's opening the browser to let me do anything, it's actually asking me what it is I want to do. So I'm going to tell it to connect to the network. So you can see here that it's actually building, it calls them circuits, but it's building this network. It's connected itself to the entry node, and now it wants to know what I want to do. So I'm going to go up here, and we're going to go to www.google.com. Now, this is a downside. You notice how long it took to bring up the Google website. So when you're navigating through the TOR system, the TOR network, it actually is a little bit it's a little bit slower than, so you're not, the point here is you're not going to go watch videos and stuff over the TOR network. The TOR network is really there to kind of give you access to things that you might not want people to know you're doing. So it may be a political, and this is probably this is one of the reasons that the CIA created the TOR network, was to give the ability for people that live in countries that are being, persecuted or whatever, to be able to communicate with the outside world without anybody being able to figure out that they were the ones that did it. And so that's why the network was created, and that's why it's used. That's one of the reasons that it's used. Now, obviously, when you create a network like this, you're going to have a lot of criminal activity on that network as well. But it's, you have to go to a website to actually, have that issue. So let's take a look for a second at how an actual TOR web server would look like, because we've already removed the DNS. We've removed the website address. You can't have google.com. Obviously, I can get to google.com on the network, but that's going out to the public world. How would I actually access a TOR web server? Because it's a little weird given the fact that I don't really have a DNS system to work with. But you do in a way. So here is basically what is going to happen. So let's get rid of google.com, and we're going to create another network now, or another web server. So this is going to be our web server that we're going to create, and this is a TOR. This eraser thing on this thing drives me crazy. TOR Web Server. Now, one of the nice things about this is because there is no DNS system, you don't have to pay for this web server. And because there's no DNS system, there's nobody controlling whether it's up or down. So with the DNS system, the one that the government uses or the public world uses, if somebody doesn't like your website, say they don't like the information on it, maybe the U.S. government decides that they don't want your website online because they feel like it's, creating dissidents, or, it's sharing information that they don't want shared. Well, they can just take the DNS down. They can just say, they can call the DNS server, the people managing the DNS system, and say that we don't want this IP address or this particular domain to exist anymore. And they just delete it and it's gone. But in the dark web, they can't do that because there is no central management of that domain there, or that website address. And so as a result, and because these websites are actually encrypted, so you may have a website that looks something like, ABC45ZYXZ, and it's actually a lot longer number than that. This makes it also impossible for a bot, like in a public environment, a bot like Google or DuckDuckGo goes around and they write software that goes around and bounces to all these websites and consumes what is on that website, so that it can share that information on Google in order for them to sell ads and get people to come to their search engine. Well, on the dark web, you don't really have an environment like that. Now, there are central websites that you can go to in order to try to find other places, but typically a website that's on the TOR network is going to be shared between individuals, or it's going to be shared, in a criminal organization or whatever it happens to be. And they're the only ones that are going to know what that IP address or what that website address is, because as you can see, it's very cryptic. So they would literally have to write this down in order to get to it, or to have some link somewhere that they can click to get back to that website. So when you're on the dark web, you're kind of blind in a lot of senses, because you don't really know all of the different websites and things that exist on the dark web unless you're invited to come to the particular website. So you're not going to go to google.com and search for a domain or search for a website that's out on the dark web, because there's just no way to get to it unless you have the full address of that particular web server. And so what it does is it actually protects you, because nobody out on the internet, your ISP, the FBI, the CIA, nobody actually knows what you're visiting inside that dark web, because all your traffic is bouncing all over the place. So, and everything between your TOR browser and the internet, or between that dark web, it's all encrypted. So there's really, other than the fact that you may store information on your personal computer that came from one of the dark web servers, there's really no way for anybody to know what you're doing. So it's completely protected from that standpoint. And actually, I just realized that my I'm going to have to go back over here and redo this because it's no longer recording. So in the video, while I was talking about what I was doing here, I erased the google.com up here. We just created a TOR web server, and this is the example of an address that you would have for that particular web server. I apologize, I forgot that my iPad turned itself off and I lost the connection. So that's all I did is I drew the web server, got rid of Google, and then wrote that number. But the point is that if I know an address, I can get to it, and everything is actually encrypted and secure. And that really is all there is to the dark web. It's just it is a place that can't be controlled, it can't be tracked, it can't be manipulated in a way that is going to allow you to, or allow someone else to be able to see what you're actually doing on the dark web. And so just a couple notes. Obviously the ISP can see that you're actually going into the dark web, and they can see that you're communicating with the dark web, but they're not going to have any idea what it is that's going back and forth. All they can do is see traffic that's moving back and forth. On the exit node side, if you're going out to the public web, then it's possible for them to see that you went to google.com and logged into my email address, for example. Well, if I did that, then they're going to be able to track the fact that my email address actually came out of the dark web node, and therefore they know that I'm the one that at least sent that traffic through the web. So that's something that could be tracked. Now, if I am actually on the dark web and I'm accessing a server that's on the dark web, well, that is pretty much untraceable. There's no way, because they don't even know where that server is on the dark web. Like unless they have that full encrypted hash code that represents that server, they're not even going to know where that server is on the web. And so me visiting that, they couldn't prove that I actually went to that website and looked at it at all. So it's a very secure mechanism if you're accessing things that are on the dark web itself, because in that case there wouldn't be an exit node. You're actually staying inside the network, and so it's very secure. But again, they would be able to see that you're actually going into the TOR network. They just don't know what you're doing while you're in there. So that's basically what a TOR network is, what the dark web is. When you hear people talking about the dark web, it's not some nefarious, obviously there can be a nefarious side to it, but it's not like you're going into the dark web and entering a criminal organization and the CIA is going to come get you because you're breaking the law. It is a completely open environment. It's open to anybody that wants to use it. Like I said, there's all kinds of web servers and stuff in there doing all kinds of things, some good, some bad, but it's just a bunch of people that don't want the government and big corporations knowing what they're doing. They don't, even if they're not doing anything illegal, they just don't want the government being involved in it because they're tired of Facebook and Twitter and Google and all of these companies tracking every single thing that's going on, and so they just set up their own web servers and they do their own thing. That's basically what it is. And again, when you get in an environment like that, you can have a bad side, but you either have to find that domain or be told about the domain in order to get to it. It's not like you're going to go to google.com and find it. So in that respect, even though there is a criminal element, it's no different than you walking down the street. There's criminal elements all around you. Your neighbor could be a cocaine dealer. You don't know. You're just walking your dog down the sidewalk. There's all kinds of nefarious stuff going on around you, but you're just walking your dog down the sidewalk. So you're not involved in what they're doing. You're just participating on the same street that they happen to live on. So it's really no different than that, and it's not, not anything more scary or criminal than that. So hopefully you now understand what a TOR network is, and maybe you go play around with it and see what you can find. It's just an entirely new world.